what we are looking at graphing. We are doing a different way to graph today. So instead of graphing like we did on the warm-ups with x and y or with y slope-intercept form, we are going to look at graphing by the intercepts. Okay, so as I look at this, okay, let's see. This is still section 4. This is 4 what? 4 point what?
4.
Is it 4-4? Check the last notes. 4-4? Pretty sure it is. 4-4. So we are looking at 4-4. So Unit 4, Section 4. So when we look at the Unit 4 test, which we'll have in a couple weeks, we are going to be, guys, we're going to be looking for all of your Unit 4 notes. So if you're absent, you need to get on Google Classroom. If you're here, you need to keep them in a folder or something, or you can keep them in a folder in that closet. So when I check the Unit 4 notes, you can just pull them all out. Easy 10 points. Easy points. You guys can all pass if you get easy points. So what we looked at on the warm-ups, which yesterday is 10 days ago, but what we looked at on the warm-ups is how to graph a linear equation by using a slope and y-intercept. Today, we are going to graph using the x and y-intercept. Okay? So when I say the x and y-intercept, we talked about the y-intercept before. What's the definition of the y-intercept? Look at your notes from before break if you need to. We talked about a y-intercept. What was the definition for the y-intercept? No, that was a slope. Slope was rise over run. The y-intercept. What do I mean by the word intercept? Not necessarily where two lines cross. Kind of close. Someone say it. Point. A little more specific. It is a point.
On the y-axis.
More specific. It's a point on the y-axis where what happens?
X crosses through.
What crosses through?
X.
No. It's the point on the y-axis where what happens? Point on y-axis. Guys, stop the conversation. Point on the y-axis where what happens? Get your notes out. You have part of the definition. You have 2/3 of it. It's a point on the y-axis where what happens? The what? The line crosses. That's what I mean when I say the intercept. It is the point on the y-axis where the line crosses. We talked about the y-intercept before. We did it on the warm-ups. We put a point. If my y-intercept was 3, I put a point on the y-axis at 3, and then my line went through that. So the x-intercept is the same thing. Point. Are we done? Because I'm going to teach when people are done talking. Okay. Point on the x-axis, the x-intercept is the point on the x-axis where the line crosses. Okay? So when I refer to intercepts, that is the point. It is a point where the line crosses. So the x-intercept is the point where the line crosses the x-axis. The y-intercept, like we talked about before, is the point where the line crosses the y-axis. So what we're going to look at today is we're going to find the y-intercept, we're going to find the x-intercept, graph those 2 points, and then just draw a line through them. We're not going to use slope today because they're not going to be in slope-intercept form. So what we're going to look at, here are the steps. First of all, the equation must be in standard form. What does standard form look like? Yep, it's right here on the side. ax plus by equals c. Standard form has x and y, usually on the left side. Doesn't need to be necessarily. But standard form, x and y are on the left side. Slope-intercept form looks like what? Did it on the warm-up. What's slope-intercept form look like? Y equals mx plus b. Slope-intercept is solved for y. Standard form has x and y on the same side. So we're working with standard form today. So make sure it's in standard form. first thing you're going to do is you're going to cover up the y term and solve for x. So there's a couple different ways you can think this. The way, one way you can think about it is you are covering up the y term. Instead of covering up, you can also think about plug in 0 for y. So there's a couple ways you can think about it. I'm going to kind of talk both ways, so you have a couple different options, however you want to do it. But basically what you're going to do is you're going to plug in 0 where y is. If I am looking for a point on the x-axis, my y value is always 0. So if I'm looking for a point on the x-axis, my y value is always 0. So if I plug 0 in for y, which is the same as covering up the y term, and then we solve for x, and that's the x-intercept. And then we do the opposite. We cover up the x term and solve for y. So covering up the x term is the same as plug in 0 for x. So what we're going to look at, if I'm looking for a point on the y-axis, I'm looking for where x is 0. So I'm going to plug 0 in for x. Let's think about it real quick. If I have a graph, let's think about it. If I have the x-intercept, what do I know about an x-intercept? It has to be on what axis? X-intercept. X-intercept has to be on what axis? Read the definition. What's the definition I wrote up here for x-intercept? And it's a point where? If I graph the x-intercept, it has to be a point on what axis? The x-axis. So if I pick any point on my x-axis, what do I know is true about any point on the x-axis? Think about these ordered pairs. What would be true about any point on the x-axis? Not necessarily cross through y. Think about the ordered pairs. If I think about writing the ordered pairs, what do I know my y value will always be for any point on the x-axis? What will my y value be?
Last.
No, it will be last. It's the second one, but more specific. If I have any point on the x-axis, what do I know the y value is? Do I go up or down any? No, so my y value will always be what? 0. So if I'm talking about an x-intercept, since it has to be on the x-axis, it doesn't go up or down, so that's my y value is always 0. That's why I plug 0 in for y to find the x-intercept. Same thought process for the y-intercept. If I put any point on the y-axis, what do I know? Any point on the y-axis will always have an x value of what? 0, because I don't go left or right any. That's why we can plug 0 in for x and y. Because if I'm looking for the y-intercept, it's a point on the y-axis. My x value is always 0. If I'm looking for the y or my x-intercept or my y-intercept, then I know the x value is always 0. So that's why we can plug 0 in for x and y. And then we just plot both intercepts and connect. Okay? So I know this kind of seems weird, but once we do a couple examples, don't make this harder than it is. Okay? If I look at number 1, first of all, this is in what form? Slope-intercept or standard? Standard. X and y are on the left side, so this is in standard form. We could solve this for y and graph it like we did on the warm-up, but we are graphing using the intercepts today. So what we're going to do first, it's already in standard form. Let's go ahead and find the x-intercept. If I'm looking for the x-intercept, what do I know y is always equal to? 0. So I'm going to take 0 and plug it in for y. So if I'm looking for the x-intercept, I know y is always 0. So you're going to plug 0 where y is. Don't make this harder than it is. X-intercept, always plug 0 in for y. Now this is the cover-up part. What's negative 2 times 0? 0. So you can just cover up that part. So negative 2 times 0 is 0, so that part is just gone. So you're left with 3x equals negative 6. How do I solve 3x equals negative 6? Divide by 3. So you're going to have really easy equations to solve. Once you cover up either the x or y, depending on what you're trying to find, you have a really easy equation. 3x equals negative 6, divide by 3, x equals negative 2. How do I graph an x-intercept of negative 2? X-intercept of negative 2. Left 2. It has to be on the x-axis. And then put a point. That's all you do. So if I'm looking for the x-intercept, if I find it's negative 2, you just go left 2 and put a point. Don't make this harder than it is. If I'm looking for the y-intercept, what do I always plug in for x if I'm looking for the y-intercept? 0. So plug in 0 for x. So y-intercept, you plug 0 in for x. What's 3 times 0? 0. So that part you can cover up, just get rid of. So 3 times 0 is gone. So I'm left with negative 2y equals negative 6. And how do I find y? Divide by negative 2. So y is what? 3. And then how do I graph a y-intercept of 3? Of 3. Don't make this harder than it is. You're plugging in 0 for x, and then you're plugging in 0 for y. You're solving the really easy equation, and then you're just graphing the x and y-intercept. My x-intercept was negative 2. My y-intercept was 3. And then you draw a line connecting them. We're doing nothing with slope because it's not in slope-intercept form. We're just finding the x and y-intercepts. Okay. Any questions on that? Okay. Let's look at another example. Let's look at 5 real quick. Let's look at a couple more of these. First of all, standard form. Why is this in standard form? Okay, I need heads up. Why, Michael, heads up, please. Why is 5 in standard form? It's not equal to y. X and y are on the same side. Both of those are good. So let's graph using the x and y intercept. So if I'm looking for the x-intercept, how do I find the x-intercept? How do I find the x-intercept? Plug 0 in for y. So 4x minus 0 equals negative 4. So to find the x-intercept, you always plug 0 where y is. Don't make that harder than it is. Now, minus 0 is just kind of gone. You can just kind of cover it up. So I'm left with what?
4x
equals negative 4. Now, 4x equals negative 4. How do I solve that for x? Divide by 4. X equals, gentleman in the front corner, pay attention please, negative 1. So once you plug in 0, part of it's gone. You can just cover it up. X equals negative 1. How do I graph an x-intercept of negative 1? Left 1. Do not make this harder than it is. You can graph an x-intercept of negative 1. You go left 1. The y-intercept. How do I always find the y-intercept? It's the same process. The y-intercept, what do I plug in for x? 0. So I'm going to plug 0 in for x. So if I plug 0 in for x, that's 4 times 0. 4 times 0 is gone. You can just kind of cover it up. I'm left with what? Nope. Okay, guys in the front corner, pay attention. You're not, but we can have this argument. I'm left with what? If 4 times 0 is gone, I'm left with what? Negative y equals negative 4. How do I solve this for y? Divide by negative 1. Y is what? 4. So how do I graph a y-intercept of 4? I go up and put a point at 4. Do not make this stuff harder than it is. You guys can all do this. Okay, draw your line. Something like that. Okay. Any questions on that? Okay, let's look at one more for now. Go ahead and flip to Let's go ahead and look at. Doesn't matter. Let's look at. You want to look at 9? Sure. Let's look at 9. So if I look at 9, let's look at 9 real quick. There's not really a ton of numbers, so it's kind of weird. So as I look at 9, let's go ahead. First of all, it's in standard form, and it tells me to find the x and y intercept. So to find the x-intercept, don't make this harder than it is. You do the same thing every single time. To find the x-intercept, how do I find the x-intercept? Plug 0 in for y. So put 0 where y is. That 0 part you can think about covering up, so I'm left with what? X equals 1. How do I graph an x-intercept of 1? Go right 1. On the x-axis. The y-intercepts. What do I always do anytime I want the y-intercept? You all should be able to answer this by now. Put 0 where x is. If I put 0 where x is, you can think about covering it up. I'm left with what? No, I'm left with negative y equals 1. Don't forget the negative. Negative y equals 1. And then how do I find y? Divide by negative 1. Y equals negative 1. How do I graph a y-intercept of negative 1? Go down 1. 2 points. Make a line. Draw your line. We do one more. Sorry, I lied. One more. Okay, let's look at 10. We'll look at 10 real quick. Let's look at 10. This will be the last one for now. Then we'll start the homework. Okay, if I look at 10, x-intercepts. You do the same process every single time. What do I do to find the x-intercept? Do the same process. Plug in 0 for y. So 30 times 0 equals negative 30. So if I'm looking for the x-intercept, you plug 0 and y. You just have to, it's just something you do. Because if I'm looking for a point on the x-axis, I know y is always 0. Okay, 30 times 0? 0, so it's gone. You can cover it up. I'm left with what? What am I left with if 30 times 0 is 0? 10x equals negative 30. You guys can do this. 10x equals negative 30. How do I solve that? Divide by 10. So x is what? Negative 3. How do I graph an x-intercept of negative 3? Left 3. I need 2 points, so let's find the y-intercept. If I'm looking for the y-intercept, how do I always find the y-intercept? Plug 0 where x is. Good. So 10 times 0 plus 30y equals negative 30. 10 times 0? 0, so you can cover it up. I'm left with what? 30y equals negative 30. Okay, how do I solve for y? Divide by 30. Y equals negative 1. How do I graph a y-intercept of negative 1? Down 1. 2 lines, or 2 points make a line. Draw your line through them. So a different way of graphing, if it's in standard form, it's another way to graph. David, Preston.
I'm not doing it. I'm working.
If you're done, you still don't have to talk over me. Okay. Okay. Well. Okay, so x and y intercept. Any questions on these? Okay, let's go and pass out the homework. We have one more small section to do after this.